In this lesson, we'll look at how to solve inequalities and solve real-world problems involving inequalities. This example shows how much cell phones have changed as well as the plans. How can inequalities be used to compare phone plans? Cooney is trying to decide between two rate plans offered by a wireless phone company. To compare these two rate plans, we can use inequalities. The monthly access plan fee for Plan 1 is less than Plan 2 because $35 is less than $55. However, the additional minutes for Plan 1 is greater than Plan 2 because 40 cents is more than 35 cents. For any two real numbers, A and B, exactly one of the following statements is true. Either A is less than B, A is equal to B, or A is greater than B. This is known as the trichotomy property, or property of order. Adding the same number to or subtracting the same number from each side of an inequality does not change the truth of the inequality. For any real numbers A, B, and C, if A is greater than B, then A plus C is greater than B plus C. If A is less than B, then A plus C is less than B plus C. Or same thing is true for subtraction. For any real numbers A, B, and C, if A is greater than B, then A minus C is greater than B minus C. If A is already less than B, then A minus C is still less than B minus C. Fun fact, the properties of inequality are also known as axioms of inequality because they're true across all the branches of mathematics, as opposed to postulates that are just true for geometry. And to make sure that everyone is on the same page, it's probably good to go through less than. It's the same as fewer than. The symbol is greater than, more than. Less than or equal to could be is at most, is no more than, is less than or equal to. Greater than or equal to could be is at least, is no less than, is greater than or equal to. And just in case, I thought I'd mention 1 is less than 2. 2 is greater than 1. The small end of the inequality points to the smaller number. The big end points to the bigger number. Big N, big number, small n, small number. Some people are confused by what the symbols mean. Hopefully that's helpful. To solve, we want to get our variable on one side by itself. So it's nice with inequalities to get our variable on the left. It makes life simpler when you go to graph. So I'm going to subtract 5y from both sides of the inequality. 4y minus 5y is negative 1y. We don't normally write the 1. And the 5y's are gone. And then we just need to add 3 to both sides. So we have negative y is less than 5. And finally divide by negative 1. And big idea to remember, when we divide by a negative, we have to reverse the inequality. And it says graph the solution on number line. Okay, so I'm going to make my not yet patented, patent pending, lazy number line. I always like 0, but the only number we really need is negative 5. Open circle in the negative 5, and y is greater than, so our arrow goes to the right. Now, when we do check steps for inequalities, that's a little bit different. Where this is y is greater than negative 5, if I put in negative 5, it should not give me a true statement. I'm going to check a number that is greater than negative 5. A convenient number is 0. 4 times 0 is 0. 5 times 0 is 0. So is negative 3 less than positive 2? Yes, of course it is. My check step worked, and I'm liking my answer in both the graphical and algebraic form. Okay, so again, the reason it's an open circle is the negative 5 is not included in the solution. If we use a closed circle, it is. I used the properties of multiplication and division for inequality when I solved that last inequality. If we multiply the same by the same number, it does not change if it's positive. It's all good. But if it's negative, we have to reverse the inequality. Same is true here. If we're dividing by a positive number, the relationship stays the same. If we divide by a negative, we're going to have to reverse the inequality. Again, they want us to solve and graph the solution on a number line. So to get p by itself, I'm going to divide both sides by -3/10. And we have -40. We divide it by a negative, so we have to reverse the inequality. Okay, so this is read as -40 is less than or equal to p. For graphing purposes, it's preferable to have our variable first, so that'd be equivalent to p is greater than or equal to -40. Notice that the inequality is equivalent. The small part of the arrow is to the -40, the large part is to the p. And this time it's greater than or equal to, so I need a closed circle because the -40 will be included. This time, since my inequality is greater than or equal to, I can actually put in just -40. And on the calculator, I can see that, that 12 does in fact equal, so it's greater than or equal to -3/10 times -40 is positive times negative is a positive, so that is 12. So I'm once again satisfied with my two forms of the answer. Now, I may be satisfied with my two forms, but there's another one yet. It's called interval notation. The infinity symbols for positive and negative infinity are used to indicate that a set is unbounded in the positive or negative direction, respectively. To indicate that the endpoint is not included, use parentheses. So if we wanted to write y is greater than -5 in interval notation, it's starting at -5, the -5 is not included, so we use a parenthesis, and it's going towards positive infinity. If we wanted to do p is greater than or equal to -40, they use a bracket to show that the -40 is included in the solution. And again, it goes to infinity. Now, the infinity signs will always have a parenthesis next to them because by definition, you never get to infinity. This is a passing note on the interval notation. This textbook, even though it introduces it, does not use it in solving their problems in the problem set. It is good, however, for you to be exposed to it because the next course you take will use it. So this is a little preview. Okay, again, we're solving graphing on the number line. To undo divide by 2, we're going to multiply by 2. So I got -2x. I multiply by a positive, so my inequality stays the same. Is greater than x minus 7. The times 2 divided by 2 just canceled out. I want to get x on one side of the equation, or inequality I should say. So I'm going to subtract x from both sides and have -3x is greater than -7. The x is canceled out. And then we're going to divide both sides, by -3. So we're going to have x is less than 7/3. So we want to open circle on 7/3, arrow goes to left. Okay, the directions do not say to check, but it's always a good idea. I can see that 0 is less than 7/3, so that's a nice happy number. A nice convenient number to work with that's less than 7/3 is 0, so every place there was an x, I'm replacing with 0. The opposite of 0 is a nice number called 0. I think you've heard of it. 0 minus 7 is -7 divided by 2, and yes, 0 is greater than all the negative numbers, so my check step worked. Just for fun, to look at what the interval notation would be, we start from left to right just like we read in English, and it's going to be -infinity to 7/3. The 7/3 is not included, and the infinity is never included. So that's what that would look like in interval notation. It is possible that when you solve an inequality, you could arrive at a false statement. So your variable dropped out of both sides, and you have something like 3 is greater than 5. No, it's not. So then the solution for that inequality is going to be the empty set or the null set. If you arrive at a true statement, such as 3 is greater than -1, yup, sure enough, then the solution set is a set of all real numbers, to which we like to write the cute little infinity symbol. Oh my, you can see how outdated this textbook is yet again. Alita has at most $10.50 to spend at a convenience store. She buys a bag of potato chips and a can of soda for $1.55. Now that's not so far-fetched as if gasoline cost, hallelujah, $1.35 per gallon, Yep, it did at one point. How many gallons of gasoline can Alita buy for her car to the nearest tenth of a gallon? Okay, we're going to choose to ignore the fact that our numbers are outdated and just work with them. They say the cost of soda chips was $1.55 plus the cost of gasoline is going to be $1.35 per gallon. They use G for gallon, that makes sense. Has to be less than or equal to $10.50. So to solve, we're going to subtract $1.55 from both sides of the equation. And we get 1.35 G is less than or equal to 8.95. I'm going to divide both sides by 1.35. We don't need to worry about reversing the inequality because we're dividing by a positive. So we have G is less than or equal to. And on my calculator I have 6.6296 and so on. They said to round to the nearest tenth of a gallon, so it would be 6.6 gallons. Nice sentence summary. She could buy at most 6.6 gallons. She could buy 6 gallons, she could buy 1 gallon, but she can't buy 6.7 gallons. Adding the same number to or subtracting the same number from each side of an inequality does not change the truth of the inequality. When you multiply or divide each side of an inequality by a negative number, remember the direction of the inequality symbol must be reversed.